Guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 167, 2SUM2. So here the given input array will be sorted. Okay, so the problem statement is they will be given you a integer array of starting with index 1. Okay, and that integer array is in an ascending order, and also they will be giving you a target value. Now your job is to find which two values in that integer array which sum up to give the target value. Okay, and we want to return those index values. That's it. Okay, and they have also given you the conditions. What are those conditions? The first condition is it should the question statement itself, the example itself, or the input itself have exactly one solution. Okay, and we should not take same element twice. For example, if this is the given value, okay, 2, 7, 11 and 15, and target is 9, then I can tell you that 2 and 7 gives me the target 9, right? Okay, so what is the answer? It will be 1, 2, because 2 is the first element and 7 is the second element. Okay, similarly here also 2, 4 will be summing up to give the value as 6. So 1, 3 will be my answer. Here minus 1, 0 will be summing up to give minus 1. So here 1, 2 will be my answer. Hope you understand this. Now let's build the logic for this. The first thing that comes into my mind is brute force approach, right? So how we are going to write the brute force approach? So it is so simple. Already we know we are going to do all possible combinations among them and find the target value. That's it. So take for example, I am just starting from here. Okay, from here. Now I will be just adding these all combinations, in its right side, and whichever combination that gives a target, then that's going to be the value. Yes, that's going to be the answer. So 1, and first of all I will be traversing here 1, 2, which is equal to 3. So 3 is not equal to target. 1 plus 3 is equal to 4. 4 is not equal to the target. 1 plus 7 is equal to 8. 8 is not equal to target. So what comes next? Next, go to here and go with the right hand side elements. Okay, now 2 plus 3 is equal to 5, which is not equal to target. 2 plus 7, which is equal to 9. So this is going to be target, this is going to be target. So what is my answer going to be? My answer is, what is this index value? It is 1. So 1 plus 1 is equal to 2, because here the index is starting from 0, but in our question it will be starting from 1. That's the reason I am adding 1 here. And here 3 plus 1 is equal to 4. So this is going to be my result. Now tell me, what is the time complexity? So the time complexity will be O of n square, because we are just taking each and every value of n elements and again traversing the whole n elements. So n into n, which is equal to n square. And what is the space complexity? It will be O of 1, because we haven't taken any auxiliary space. Fine. Now whether we can further optimize this. Okay, let us check whether we can further optimize it. So here the extra time, the n value is there because we are going on and searching here, right? Yes. So instead of searching like this, whether we can use some other data structure that will be helpful in terms of searching. So I'll be taking a hash map, because we want both the index and also the value of that particular index, right? So that's the reason I am taking the hash map. Now I'll be pushing into the index, pushing into the hash map like here 0, 1, 2 and 3, right? Now I'll be traversing one by one. So what is this value? It is 1. So value is 1, and what is its respective index? It is 0, but in question it will be 1, right? So I'll be pushing like 1. Now here it is 2, so 2 and 2. So key going to be 2 and value is also going to be 2. Next 3, 3. Next 7, 4. Now hope you understand how we are pushed into the hash map, right? Now the next thing we are going to do is we are just going to traverse once again, or we can also do that whenever we are inserting itself. Now hope you understand how we are going to insert it, right? So just come up with me, just a minute. Here I'll be just checking 1 here, right? So 9 minus 1, which is equal to 8. Whether 8 is inside the hash map? No, right? So now you can push into it. Okay, now go to the next index. It is what? 2. So 9 minus 2, which is equal to 7. Whether 7 is inside this hash map? No. So just go and insert 2 here. Now 3. So 9 minus 3, which is equal to 6. Whether 6 is inside this hash map? No. So 3 and its particular index. Okay. Now 7. So 9 minus 7, which is equal to 2. Whether 2 is inside this hash map? Yes. Yes. At this particular point. So what should I return? I will be returning like, what is it index? It is 2. So 2, comma. What is it index? It is 3 plus 1, which is equal to 4. That's it. So this is my answer. Can I understand this? You can just you can just add every elements into the hash map, and then you can go with the traversing technique, or whenever you are traversing itself, you can already check like this also. Okay. Now hope you understand this. Now tell me, what is the time complexity? It will be O of n log n, because we are traversing n times and we are inserting and accessing through the hash map. So for that, it will be log n in the worst time complexity, and space complexity will be O of n, because we are using an auxiliary space called hash map. Okay, so this is going to be your second approach. Now whether we can just optimize this, because here we are taking a space, right? Instead of taking the space, whether we can optimize it. Yes, we can optimize it. How? We are going to use binary search, because the array is sorted. Whenever the array is sorted, you are going to think about the binary search algorithm. Okay, so how I am going to do a binary search algorithm? First of all, I am at this point, this one. Okay, then I will be doing rest of them, rest of these values, whether these all that matches with this one or not. I just do a binary search among these. Can I understand this? So here comes my L pointer and here comes my U pointer. Yes. Now what is the mid? Mid is going to, so I will be neatly drawing down. So first of all, I am at this particular point 1, right? So 1. Now what are all remaining things? It is 2, 3 and 7. So now my L pointer will be here, my U pointer will be here, and here comes the mid pointer. If you know the binary search already, you can understand this clearly. If you don't know about the binary search, I'll be giving the binary search link in the description. Just go and watch it so that you can understand this clearly. Okay. Now 3. Now 3 is the midpoint, right? So 3 plus 1, which is equal to 4. Whether 4 is equal to target? No. Whether 4 is less than target? Yes. Yes, 4 is less than 9, right? So if I move towards the right side, then I may have a better value, right? So move this L pointer towards mid plus 1. So L pointers will be moving here. Now L is a mid, so mid will be this 7, right? Now 7 plus 1, which is equal to 8. 8 is again less than 9. So now what I am going to do? L will be mid plus 1. So now L pointer exceeds the U pointer. Now I can definitely tell that for this particular index, I don't have any solutions. So go to the next index for this 2. So 2, and here comes 3 and 7. So here it will be L, and here it will be U. Now what is the mid? Mid will be this 3, right? Again, I am telling you, if you don't understand, or if you already didn't come up with the binary search, then you cannot understand this approach. Okay, fine. Now mid will be this 3. Whether 3 plus 2, which is equal to 5. 5 is equal to 9, no, which is less than 9, right? So at this particular point, what should I do? I will be going L is equal to mid plus 1. So L will be at this particular point. Now mid is 7. Now 2 plus 7, which is equal to 9, which is equal to 9. So at this particular point, I can tell you that 7 is going to be my one answer. So what is the 7's index? Index is 3. So 3 plus 1, which is equal to 4. So what is this 2's index? It is 1. 1 plus 1, which is equal to 2. So 2, 4 is going to be my answer. Yes. Okay. So what is the time complexity? So time complexity will be over n log n, because for each and every value we are going with the binary search. So n into log n. Now what is the space complexity? It will be O of 1, because we haven't used any auxiliary space. We just use the algorithm. That's it. Okay. Now whether we can further go with any other approaches, so that I can reduce this log n. Whether I can go with any other approaches? Yes, you can go. You can go with the 2-pointer approach. Okay. How we are going to implement the 2-pointer approach? As you know, this array is sorted. Okay. So I'll be taking 2 pointers. So here it will be L pointer, and here it will be right pointer. So left pointer and right pointer. Now, so let me put the indices. Okay, now whether 1 plus 7 is equal to 8. What is the relationship between 8 and the target 9? So 8 is less than 9, which means we want to get a maximum value or greater value than this. If I want the greater value, where should I move? Whether I want to move this side or I want to move this side. I want to move towards the right because it is in an ascending order, right? So if I move towards the right, I may have a chance of getting a higher value, right? So I will be moving here. Now 2 plus 7, which is equal to 9. Yes. So 9 is equal to 9, right? So I have attained the target. So at this particular point, I will be returning 2, 4. So this is going to be my answer. So let us have some other example so that it will be more clear. So 1, 2, 3, probably anything like okay, 7. Now target is equal to 5. Okay, for example, now I will be standing here and here, right? Now what is the here it is L pointer, here it is R pointer. Now what is the sum? It is 8. 8 is greater than 5. So where should I move? I should be moving towards the left side. So I will be moving towards the left side. Okay, now 1 plus 3, which is equal to 4. 4 is less than 5. Now where should I move? I should move towards the right side. Okay, move. Now 2 plus 3, which is equal to 5. So 5 is equal to 5. So at this particular point, what is going to be my answer? My answer is going to be 0, 1, 2, 3, right? Now it will be 2, 3. So this is going to be my output. Can I understand this? Yes. So we are just following this approach because the input array is a ascending order, right? Now tell me what is the time complexity. So I can tell you the time complexity will be O of n and space complexity will be O of 1. So this is the much more optimized approach, right? So totally we have finished 4 approaches. Now let us see the coding path. So if you want other 3 approaches, I'll be giving you in the description. Just go and watch that. Now I'm going to take the optimized approach. Okay, and if you want the Python or C++ code, you can also go and watch the solution. There I have given the Python and C++ code. Okay, now come here. Here I am implemented using the Java code. Normally I will be implementing using the Python code, but as many of you are requesting for Java code, I am just implementing it in Java code. Okay, fine. So see here, left is equal to 0 and right will be what? Last element in this. So numbers dot length minus 1, that last element in this. Okay, now while left is less than right, what should I do? I'll be going and adding those left in this value and right in this value and taking that in a variable. Okay, then I am checking whether that particular variable is equal to the target. If it is so, I can directly return that's going to be my result. How? Left plus 1 and right plus 1, that's it. Yes, LF, what is other condition? If sum is greater than the target, greater than the target, then at that particular point, what it implies, I want to move towards the left side, so that I will be getting a smaller value as a sum in future. Maybe it may be equal to the target, right? So that's the purpose I am using what? Right minus. Else I want to move towards the right because I want the greater value, right? So at that particular point, I will be moving left to plus because here sum is less than target, right? Okay, and here it is a dummy return because in Java it won't allow us without return value at bottom, right? So for that I have given a dummy return. So let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts, you may ask in the comment section. Thank you.